Welcome back on the Space Info podcast. Today we talk about space weather. First of all, I'd like to thank you all that listened to the previous episode and maybe you've left a positive review under the episode. A huge thank you for supporting the Space Info community. Don't forget that you can also join us on the website at www.spaceinfo.club, where a lot of exclusive content from members is reserved to you. But don't forget that being a member is completely free. You just need your email and then you sign up, and you can access a lot of content, interviews, experts, talks, and a lot of more. But now to the main topic of today, space weather. Well, space is not just a static void, it is a dynamic arena where celestial bodies interact with one another and where invisible forces create a symphony of activity known as space weather. While we often think of weather as a phenomenon limited to Earth's atmosphere, actually space weather involves the dynamic condition of space that can affect both our planet and also the broader solar system. This weather is the result of the constant interaction between the solar wind, a stream of charged particles emanating from the Sun, and the Earth's magnetic field. Indeed, we observe the space weather for the effect that it has on our lives, so we are looking from the Earth, and that's the main topic of today's discussion. This interaction creates a complex and dynamic system of electromagnetic forces, giving the rise to a range of fascinating phenomena, and today we talk about this phenomenon a little more. First of them is the solar wind and how it is impacting on our lives. Well, we have to think about the Sun as a sort of powerhouse of the solar system. Indeed, the Sun continually emits a stream of charged particles, mainly electrons and protons, known as the solar wind. As this solar wind reaches Earth, it encounters the planet's magnetic field. If you're curious about Earth's magnetic field and you want to know more, let us know in the comments or in the reviews. I will write an article and an episode of the podcast and we'll talk about that. But now let's get back to Earth, whose magnetic fields acts as a protective shield, deflecting and channeling the solar wind around the planet. However, this interaction is not only always smooth. When the solar wind carries strong magnetic fields, particularly strong and stronger than usual, can connect with the Earth's magnetic field, leading to a transfer of energy and particles toward the planets. But this is not the only phenomenon that we can observe. Particularly, we can talk about the geomagnetic storms. One of the most dramatic consequences of the interaction of the solar wind with Earth's magnetic field is the occurrence of geomagnetic storms. These phenomena are triggered by intense solar activity. They can have a profound impact on the planet's magnetic field. As the solar wind collides with the Earth's magnetosphere, it can create disturbances, causing the magnetic field lines to connect with each other and release energy. While auroras are beautiful outcome of geomagnetic storms, these storms can also have adverse effects on technological systems. Strong geomagnetic storms, particularly, can interfere with satellite communication or even disrupt power grids, and even pose risks to astronauts in space. But now let's talk about another phenomenon that maybe you have observed if you are following us on Instagram when we publish some photographs of the Sun. And yes, we are talking about solar flares and coronal mass ejections, CMEs. In particular, solar flares are sudden bursts of energy coming from the Sun's surface, releasing intense radiation across the electromagnetic spectrum. Well, coronal mass ejections, on the other hand, are massive eruptions of solar material into space. That's the difference. When these phenomena are directed towards our planet, they can cause significant disturbances again. The energetic particles emitted during the solar flares can interfere with communication signals and navigation systems, for example. Coronal mass ejections, with their vast amount of charged particles, can induce geomagnetic storms, as we said before, amplifying the impact of Earth's magnetospheres. So you have probably understood that these phenomena coming from the Sun are particularly relevant inside the telecommunication world. When more and more satellites are put in orbit, the effects of the space weather on technology and communication systems are a growing concern, because satellites in orbit around the Earth are particularly vulnerable to the charged particles and increased radiation during the storms. The space weather-induced disturbances also can lead to satellite malfunction, affecting communication networks, where forecasting, navigation systems, and so that. Also, you have to consider that airlines consider this phenomenon as a threat, in particular because they face challenges during severe space weather events, because increased radiation at higher altitudes of the atmosphere impacts also the passengers and the crew. But maybe you are asking yourself if there is a way to forecast the space weather and to predict how the behavior of the sun will be today, tomorrow, the next month, and over the years. Well, exactly as atmospheric meteorological forecasts, there are a lot of agencies around the world that try to predict how the sun will behave tomorrow, today, or in the upcoming months. This is a relatively new science, so a lot of things are still to be understood, but we are trying to gather some signals and also to build some mathematical models of the sun in order to understand its behavior and how it will behave in the next months, for example. But what we have to understand, in the same way as we are trying to understand Earth's climate change, is that there are some phenomena that are connected to the daily to daily time scale, but also some secular scale phenomena. We have to think that a sun cycle, full sun cycle, usually lasts something around 11 years, and then the cycle begins again. So this is a more secular phenomenon. On a shorter time scale, for example, we observe sunspots. We try to understand how they move in order to understand how the matter will be ejected through the solar flares, or also coronal mass ejection, for example. So how the solar wind, how many particles, how big, how massive are there, and how many of them will reach the Earth and will interact in the end with the Earth's magnetic field. So this is just a little preview, some little understanding of how the space weather can behave, but in any case the sun is usually the root cause of the space weather and how these particles are emitted and then reach our planet. We don't have to stop our thinking about Earth only. It's basically essential to recognize that space weather is a universal phenomenon and it extends beyond our planet. Other celestial bodies, for example, from the neighboring planets like Venus, the Moon, which is not a planet for sure, but Mars and Jupiter, and also the other planets, are experiencing the same effects of the space weather. Basically, they have the same source of energy, which is the sun, but maybe they have different atmosphere, so a different kind of particles, different amount of charge and massed particles usually reach the surface. So there are different behavior on that planet, but the space weather is also present there. Jupiter, for example, has a powerful magnetic field, so it counters intense radiation belts and auroras. Mars, lacking of a robust magnetic field, is more susceptible to the solar wind, which continually erodes the atmosphere, for example. Even the icy moons of the solar system in the outer part of it, like Europa and Enceladus, face the influence of space weather as they orbit within the magnetic fields of their planet. So you can understand that space weather is a captivating and also intricate dance of electromagnetic forces, mainly connecting the sun to every corner of our solar system. We cannot forget that we are living on Earth, but also other planets are affected by these phenomena. Also, we have to continue to explore and harness the benefits of space, understanding and predicting space weather becoming increasingly crucial in our exploration. On one hand, we have the huge beauty of auroras we can observe from our planet, and also they can be observed on other planets like Jupiter, as we have said. The main message is that the solar system is entirely interconnected. The sun influences all the planets inside that system. Through ongoing research and technological advancement, we strive to unravel the mysteries of the space weather, ensuring that as we venture into the final frontier, which is outer space, we also are fully aware of what can happen, so that we'll be prepared for a future human exploration plan, for example toward the moon and also to Mars and the outer solar system in the very distant future. Anyway, that's all for today. Again, I thank you for listening to this point. Don't forget to leave a positive review of this episode, share it with your friends, family and loved ones, and don't forget to join the Space Info Club on our website. See you next time.